got Ronald Hoek and Rudolf de Vetten. They're they're with Blue Radix. So I'll give their bios in order. We've got Ronald Hoek is CEO of Blue Radix. He graduated cum laude in marketing. He has worked for more than 15 years on energy transition and data-driven solutions in the greenhouse industry. Hoek combines smart technology with business challenges, applying the principles to agri-food and energy sustainability, as these are domains with global and societal impact. His passion is to translate innovations into robust new business models with a purpose. In 2019, he founded Blue Radix with two colleagues. One of them is Rudolf de Vetten, who is also joining our webinar. Rudolf graduated cum laude at Technical University in Delft. He has over 15 years of experience in IT development, product innovation, and consultancy. He worked for Siemens, Capgemini, Priva, Agroenergy. Rudolf is responsible for product strategy, project management, and data science.
Yeah, great. Thank you for the introduction. Great to have us here. Thank you for that. We would like to proceed on the presentation of Silke about algorithms, how algorithms can feed the world. As Wade already told you, we've been participating in the Autonomous Greenhouse Challenge of 2018, and we decided to bring this to the market under the name of Blue Radix with a product called Crop Controller. Following the nice introduction of Quaid, I will skip this slide and tell you more about Blue Radix. You might have heard about us already in the media, especially the last few weeks. We've been conducting a lot of media attention about Blue Radix as an AI specialist for the international greenhouse industry, but also about Crop Controller, our solution in the field of autonomous greenhouse management. Blue Radix is a team of 15 experts, you could say. We're a multidisciplinary team with experts on the field of AI, also IT, and of course cultivation and energy. And energy always has been an important part of our work. While we have been developing and working on autonomous energy management in the Dutch greenhouse industry for the last 7 years. And in this period, we learned how to work with these algorithms, how they can steer operations in a greenhouse, and how they can optimize results. And we're steering 300 CHP installation across the Netherlands at 130 big greenhouse companies throughout the company. And as I said, in 2018, we participated in the Autonomous Greenhouse Challenge. And the setup of that challenge was a little different, but for a big part also comparable with things that Silke told us. We were competing with companies like Microsoft, Tencent, and Intel, big tech companies who entered the greenhouse industry. So we had to compete with them on the implementation of artificial intelligence. So we were very proud to defeat Microsoft, the winner of the first challenge, on this specific part. We've been awarded with the Dutch Data Science Prize in 2017, and well, we have been nominated for several innovation prizes in the last 2 years. Normally, I would ask this to the audience, if they do think algorithms can replace the green fingers in Canadian greenhouses. Well, this is a virtual presentation. We decided not to ask for a reply, but it's something you can think about within your own company, what you think about this question, about this statement. So what's Blue Radix all about? Well, our mission is to enable smart horticulture, and the way we do that, in the way we add value to the industry, is that we add automated intelligence, or you could also say artificial intelligence, to the daily decisions in the greenhouse. So we're not about setting the right crop strategy, but we are in the business of supporting, helping, taking over daily decisions in the greenhouse so the grower can focus on the crop strategy. That means, of course, that our solutions integrate deeply with the ecosystems of greenhouse. And our experience, 7 years on autonomous energy management in greenhouses, is that you cannot send a grower a link with some software or put a DVD inside a computer and say bye-bye to the grower. You have to be supportive, you have to offer a service, you have to help him, especially in the first period of time where he has to build trust with the algorithms. So we are offering operators who look over your shoulder when you're working with the algorithms in your greenhouse. It's quite simplistic image, but it gives an idea of how we look at the current situation in most greenhouses all around the world. On the left side, you see the greenhouse with the energy installations, the climate computer, the sensors. Below, all types of data sources which you have to work with. And on the right side, you see a grumpy grower who has to interpret all that data in all these different dashboards that he gets from sensor suppliers, the climate computer, energy companies. And he has to think about what he has to do. And it's not becoming more simple, but it becomes more complex because of all the data that is available. So what we say at BlueRadix, you should put crop controller in between. And that means that all the data coming from the greenhouse, coming from external data sources, go directly in the crop controller. And that's very important, also the crop strategy of a grower goes into the crop controller. And I will give you some more words about how that should work. Crop controller is a combination of solvers, of algorithms, and can make out of all these data points and the crop strategy of a grower the best possible combination of set points that go directly into the greenhouse. Like I said, we combine this with an operator, the BlueRadix operator for support, where you can ask your questions, where you can discuss together what is happening, why the algorithms are taking a certain decision, and it can also help you to take control if necessary. A step deeper into the model. How does it work? At first, we always start with a crop strategy. Every grower has a crop strategy, but not every grower has a structured crop strategy. So we help to structure the crop strategy, make it translate the ideas the grower has into specific data points. And we use these, you could say, data points as input for a next step of crop controller. And then you can think about how generative or how vegetative do I want my plant to be? Which direction do I want to go with my strategy? What is my aim for the coming days? What is my aim for the coming weeks or even for coming year? We use these crop strategy parameters in combination with the climate data, the weather forecasts, and if there are available also data from plant, for example, from sensors like we discussed already with Silke. And we use all the data to calculate the best possible combination of balances between light and temperature, between CO2 and light, humidity and temperature. And we also calculate the combination between those combinations. So the result of all these calculations is a multi-day climate forecast. And that means that you can see the climate for the coming 2 days in terms of temperature lines, humidity lines, CO2 and light. And these lines are the result of the optimizations of the previous step. So you know more or less already where the algorithms will take your climate in your greenhouse, to which level they will steer in the coming days, coming hours. Of course, every greenhouse is different, and the weather situations are changing. So every 15 minutes, we calculate again this climate forecast, and we use it as an input for the next step, which is set point optimization. The set point optimization uses the historical data from a greenhouse, climate data, to learn how this specific greenhouse operates. Every greenhouse has a different dynamic. So we use this climate profile with these dynamics, and translate that in the best possible combination of settings for the coming 15 minutes. Every 15 minutes we recalculate that. And that can be that there are no settings at all changed, or there might be 15 set points that are changed at one specific moment in time. There can even be that it's 30 set points that have to be adjusted. And their only target, their only purpose is to realize the crop strategy that the grower has defined. And these set points, these settings, are put through to the climate computer to get adjusted. So this is calculated every 50 minutes, like I said, and always as a grower, you're always in control. So if you do not agree with the results of the calculations and the optimizations and everything, you can always step in, because it still is your crop strategy and your greenhouse climate. And this is in more depth how we translated all the lessons learned from the Autonomous Greenhouse Challenge in 2018, and what we're doing right now in 10 greenhouses across the Netherlands, bigger tomato, cucumber, and bell pepper growers. Because the biggest challenge for the whole industry is that all the ideas, all the sensor initiatives, all these ideas on artificial intelligence are going to work when you put it into action, into a production location in the sector. And the final step in this model is about crop registration. And like Silke already concluded during her presentation, is that there is a lot to gain in this field. Visioning technology, better sensors. So we're also conducting several researches on which sensors provide the best possible information, not only for climate optimization, but also for optimizing your crop strategy. But for now, we have to work with what is available. As a human, you always also work with what's available. So in this part, in the data crop registration, a lot of human interference is still needed. A lot of human visioning is needed, you could say. So I hope this gives you an idea of how we put it into practice. And now I want to show you a short 1.5 minutes video.
From now on, autonomous greenhouse management is available for every greenhouse in the world with an internet connection. The greenhouse industry is on the rise. Profitable and sustainable growing, however, requires human knowledge and experienced control of climate and energy usage. But experienced and skilled growers are hard to find, making greenhouse operations a challenge. This is why Blue Radix introduces Crop Controller, a Dutch-developed solution based on algorithms that optimizes and steers your daily greenhouse climate and energy usage autonomously in a way far beyond human capability. Crop Controller uses external data sources like weather forecasts and energy prices, and combines it with your historical and current data from sensors and climate boxes. Algorithms then use all available data to make the best possible decisions on climate and energy usage, and automatically steer your installations. This smart service optimizes your greenhouse operations continuously, 24 hours a day, 365 days a year. And it's not only software. Blue Radix combines autonomous greenhouse management with off-site operators to monitor your greenhouse 24/7 and to support you, while our algorithms are working and steering for you at the level that you prefer. Crop Controller helps you reach higher yields while minimizing costs, resources, and unnecessary risks, making your greenhouse operations scalable so you can manage more hectares. Would you like to know more about how easy it is to get started with Crop Controller? Let's get in touch.
So now I want to give a word to my colleague Rudolf, who will present to you the second part of this presentation.
Yeah, thank you, Ronald. Just share my screen. Yeah, that was cool, wasn't it? We, in a very short video, we tried to tell you the message, but I will go a bit deeper into what we are actually doing with Crop Controller and how we implement it also in organizations of growers, because that's also a big step, how you actually can work with these kind of algorithms when you're not an IT expert, because you shouldn't be that to be using these models. Well, what Ronald told already is that we optimize multiple aspects at once. We started in 2018 with Autonomous Greenhouse Challenge, developing these models based on our experience with energy models, and then started right away incorporating the most important aspects like temperature, lighting, humidity, and carbon dioxide. From that moment on, we actually have rebuilt our models completely, because once you start in a production greenhouse, a lot of complexity is added, of course. Not a single greenhouse is the same. Every greenhouse has different installations, different layout. Crops may differ. Even if you grow tomatoes, there are a lot of varieties with different aspects that you want to take into account. So that's what we actually are doing. We start from this starting point at each greenhouse, make a complete overview of what's going on in the greenhouse, what installations are there, what capacity is there of the lighting, if there is any lighting. We look into fogging systems and all these installations that can be steered. And based on that, we fill in a crop strategy and we start optimizing. And this optimization is typically starting with a light optimization. So you start with calculating the amount of light that you will need in the coming days, combined with the natural light that is available. So we take the local weather forecast on a very detailed level. We translate this to 5-minute data for our optimization and make a complete planning for the coming days. We don't only look to the momentaneous light, so the 5-minute light levels, but also to light sums, because the amount of light, the total amount of light during the day is an important factor in determining the full day average temperature. So we both look at the effects on the very short term, so in the coming hour, 2 hours, 3 hours, but also in the coming days. And we optimize these effects together. Temperature and light should be always balanced, but if there is a lot of light, you also want to have more carbon dioxide, but still you have to look into the installations you have, how much carbon dioxide is available. What we see from our background in energy optimization in greenhouses, this helps us a lot to make this realistic. We're not calculating what it could be there in the ideal world. We calculate what can be done in your specific situation in your greenhouse with the resources you have available. So, and that is also the major updates we did in the past based on feedback from actual growers to make it really realistic. So we learn from the data we get from your greenhouse, we optimize towards an optimal goal for your greenhouse, and then we calculate the climate. An optimal climate is not always the same. At some moments, your plant will be more generative. At other moments, it will be more vegetative. And based on this plant states, if you have a very strong plant or a more weak plant and you want to get it stronger, to be more resilient towards diseases, you have to also steer your climate. And this trade-offs you have to make, that's typically where optimization comes in very handy. A lot of small decisions have to be made that have a great effect on the end. And if you do it right, you'll have a very high yield, but also low energy cost, just as Silke showed some teams reached during the recent Autonomous Greenhouse Challenge. But if you make the wrong decisions, you will end up with high yields, but also very high costs. And of course, these cost effects are very local. We know at some situations Carbon dioxide can be very costly in some situations. Heat can be very costly, or electricity prices are high. So this effects we take into account, but they're never the same for each situation. So that's the strong point of these kind of algorithms. Yes, they are developed in a standard way, but the outcome is specific for each day, for each greenhouse. It will be different. And this will really help you as a human to be supported by decisions based on a lot of data, instead of making these calculations every day again by yourself. And we see that even very experienced growers make quite some mistakes in these calculations. I won't go into the very details of the model itself. We have frequent demos. You can join them if you want to really dive into what's going on, how is this light optimization working, how is this temperature humidity balance working, how do we calculate set points, and how does it look like. Feel free to join a demo. For now, I want to tell a bit more about how we deal with plant data, because also during these challenges, we see that data from plants is very valuable, but we also see that it's still very hard to select the right sensors to steer your climate in the right way. We see a lot of sensors on the market that give you some information about the plant, but it's never a complete picture. And often you get a line, a graph in a dashboard, and still have to do the interpretation. What we do with plant sensors is that we measure the balance of a plant. So we really try to get a complete digital picture of the plant so we can steer it to a productive and healthy state. You don't want in dark periods a very weak plant that is not handled to have this low amounts of light. So you want to detect in a very early stage when your plant gets out of balance and directly steer it in the right direction. And for that, plant sensors can come in very handy, but typically you need a combination for it. And for example, we look now for, as you see on the picture, for juice flow sensors combined with load cells, combined with microclimate sensors. And we're in the middle of this project and see already some good results out of it. Not that we only monitor what's going on, but we also predict what will go on in the next days, because knowing what's going on is interesting, but being able to predict and to adapt to it, that's the big thing to reach with these sensors, of course. And we will publish the results in the near future about what we expect. It's the best combination out of this, and can be combined with autonomous growing. For this moment, what we see in the production greenhouses, when you do this observation yourself, or you make pictures and share this with our crop advisors, you can get a very good result without this sensor. So it's really an addition. It's not a necessity at this moment to be able to control your climate in the greenhouse with algorithms. We get a lot of questions about what's the difference between the algorithms we develop and all the data platforms that are on the market. You may know a number of them, like 30 megahertz or Let's Grow or eGrow. We know eGrow is also used in Canada. And these data platforms, what they typically do is they collect a lot of data about your greenhouse and visualize it in nice graphs and nice dashboards. This is very handy when you want to have a better insight in what's going actually on, what happened, as is shown here on the top level. And maybe you get even some diagnostics on it. Why did it happen? Because it can be helpful when you see there is a lot of light and the temperature was not raised enough. Your plant will experience stress. This kind of KPIs can be shown in this dashboard. We take a different approach. We say we don't want to provide additional information to growers. We want to provide action to growers. We want really to help you to take off the burden of the climate management every day. So we provide decision support and decision automation. Instead of that you have to make the decision yourself, based on your strategy, we will directly calculate the optimal set points for the climate computer and for your crop strategy, and help you to make the best decision out of it based on all the data we have from sensors and from your registrations. So that's a big difference. It's not contradicting to each other. We work very well with a number of data platforms together, because a lot of growers use these data platforms, have collected their data already over there. We give our data back to this data platform, so you have it all in one place. But we believe that you really will be able to scale once you have not only the data visualized, but also when the data is used actually day by day, minute by minute, to optimize your climate, your irrigation, your pest and disease control by smart algorithms. Well, how do you start with this in your greenhouse? Because it may seem like far-fetched to hand over an important daily task that you're doing where you need a lot of expertise to an algorithm. Is it so simple as that? In a way, it is simple because there is a very structured approach possible to get used to using algorithms in your greenhouse. We've seen this in the past also when we did this in energy optimization. It feels like a big step, but once you get used to it, it will feel very comfortable because you will stay in control all the time. So what we typically do is that we have a phased approach where you start with optimizing your daily set points that make a difference in your greenhouse, but it's not something where you make big decisions on. So the next step is that we optimize also your weekly set points. Bigger changes you make in your crop strategy and that affect set points in your climate computer. And we do this for the standard situations. So not when there is a big weather change or when you have a virus in your greenhouse that requests special attention. But later on, also complex situations will be handled by the algorithm. So at some moment, you will only do proactive monitoring, and later on even you will not rely on monitoring, you will just rely on alerts you get from the crop controller. And in the end, we believe that it will be possible that you define your crop strategy, that you set this up together with our operators, and the crop controller will handle your crop strategy in the best way according to your strategy, and you really feel comfortable with that. So this is a phased approach that will take some time because it has a big impact, of course, on your company. But we really believe this can go quite quickly as soon as you build up the trust in the system, and then there will be a day you really will be able to scale up your company because you feel like, okay, a big task is very well handled by algorithms, and that's where our claim algorithms can feed the world come from. We see there is a big lack of growers in the world, so it's not only luxury to do this. We really need all the expertise of growers for the high level creative tasks like defining crop strategy, setting out the company strategy, care about how the labor is done in the greenhouse. A lot of different tasks are to be done, and it would be very good if this part can be managed by algorithms. So more greenhouses can be operated across the globe. So in short, it's a Dutch developed solution in cooperation with prominent vegetable growers, currently focused on vegetables. We look also into ornamentals and other crops, but currently mainly on vegetables we are focused. We make the trade-off between a good climate, but also the use of energy and other resources, because in the end, profit is what counts. So you have to make smart choices on this. And it's not a one-size-fits-all algorithm that just grows tomatoes or cucumbers or sweet peppers. What we try to do is your strategy, take your idea about how to grow a crop and implement this in the decisions you make on a daily basis. So you have a full trust that the climate in your greenhouse, the irrigation, the pest and disease control is done in a way as you think is the best. So your growers and your crop experts can manage more hectares, and the dependency on humans is reduced. Well, please get in touch if you want to know more. Please ask questions after it, so Ronald and I can answer these. And for now, thank you for your attention.
Thank you, Ronald and Rudolf. So we'll move on to questions. We've already got a good set of questions coming in for you. I'll start with, do you think it is useful to do some experiments on optimization of a single environmental factor to improve crop production in the future?
I find it a bit hard to make interpretation of this question, I think. Maybe Ronald has a better...
Yes, I'm puzzling as well.
Maybe
it's about how do you think the trend to use the AI in greenhouses? Well, in a very broad perspective, AI is going to be very important in the greenhouse industry, because it's, in our opinion, the only solution for the scarcity of human experts and growers in the coming years. We see the industry growing very fast. Greenhouses are built everywhere around the world, and the amount of growers that it's experienced to get the best possible level of yield isn't decreasing, actually. So AI is a new technology, but it's already there for a few years, and it's getting more into the day-to-day operations. We've seen that on the energy side for 7 years already. When you get used to it, it's not scary anymore. It's not that specific. It's just a piece of technology that calculates optimal results and does a job for you. And it's all about trust. If trust is coming in and the algorithms are doing part of your job, and you feel the value of it, you can focus on other parts of your company. So yes, I think the trend to use AI in the greenhouse industry is there already, and I don't think it's going to stop. It's going to increase.
Shall I answer the other question of Bill? And that was about how to build a crop strategy. Do you buy a crop strategy, or is it determined by yourself? What we do is we will sit with you together and ask for your ideas about crop strategy. Some growers have very specific ideas. Some don't have such a specific ideas. We have calculation modules to optimize crop strategy and to calculate the best mix of all the resources for your crop cycle. So we plan a complete crop cycle based on local climate data, based on your results of the past, based on the variety that you're growing, and we can calculate the outcome of your decisions, and we can advise you on these decisions. If you're your own crop consultant, we will work with your crop consultant to do this. What we want is that we really understand your crop strategy, and that we really help to make it the best possible. And this will be the starting point for the daily optimization that will run after it. I see a question, how was CO2 dosing implemented? I think I can answer this also. CO2 dosing is very much depending on light, of course, and on the resources you have available. So what we typically do is that we calculate the optimal amount of CO2 based on the resources you have. So if you have a heat boiler providing CO2 or you have pure CO2, also there, the starting point will be what is your strategy and what is profitable in a way. So adding more CO2 can be, from a crop perspective, be very attractive, but if your CO2 resource source is very expensive, you want to limit this as much as possible. So this will be also an optimization that's very specific for your greenhouse.
Shall I answer the next one? I see the question about sustainability in agriculture and how AI can help with that. I'm not sure if this is a question for us or it's a question for Silke, but we do have an opinion about it. AI can help to optimize the trade-off between yield and cost, but it also in the same calculations you can think about what do you want with your energy usage. If you have a CHP installation, for instance, that CHP installation costs money. Gas costs money, and electricity can be used for lighting. In the algorithms, the right set of combinations can be made to find the best possible trade-off. When do I use light for my yield, or when do I preserve my light for a later moment because of, for example, energy cost? Of course, most growers will say yield is always most important, and my crop is most important in my decisions. But at the other hand, we see that a lot of light is used, or light is put on in the greenhouse when it's not they're necessary. You cannot put it on and off every 15 minutes, for example. Well, these algorithms and crop controller is able to perform that task perfectly. So that's, I think, also a very important step forward in optimizing the usage of all kinds of resources, like water, but also like energy.
Then I will take the next question. If my internet connection is unreliable, would an AI system work? And I think I can relate that to the other question about integration with different systems and different vendors. We are a cloud-based solution. So yes, we are depending on an internet connection, but what we do is we forecast for the coming days, for the coming 2 days. And that's not only because it's interesting to know what's going on, but also to take care that there is always good set points in your climate computer well ahead. So if you have a breakdown in your internet connection, your climate computer will still run based on the latest output that we provided. Of course, if it breaks down for multiple days, then at least we will detect it and we will consult you about it. But it's not that we need a real-time, full-time internet connection to be able to run this system. Of course, more actual data will help, but it's the system is designed for these kind of situations specifically. And we also work with multiple climate computer vendors. We're really independent for that, and that's also what we see growers really like. They want to select the best algorithm and not be tied to a specific brand of climate computer or screening or light installation or whatsoever. So we're very open to collaborate with systems that you have in your greenhouse. And well, we also have a lot of partnerships going on with different vendors. So we're used to deal with that.
Maybe the question of Kevin about location or geography, how it impacts the data sets. No greenhouse is the same. Not in one place on the earth. Even the greenhouses in the Netherlands, which are in the Westland, for example, quite close to each other, they are different in the way they act, in the way they respond to climate changes, weather changes, and that has everything to do with the setup and the way they are located. So what we do is that we not learn in terms of data sets from the other greenhouses. We use the data of the specific greenhouse to train the algorithms. And these two combinations, so the specific crop strategy of a grower and the specifics of that greenhouse, that combination makes the results always unique. So we do not believe in one recipe, one approach for a crop strategy, and we do also not believe in one set of data for optimizing a certain setup of a greenhouse. So that's definitely, it's also, it brings complexity to the table, but on the other hand, that's the way we think it's bringing the best results for every individual greenhouse.
I see a lot of questions coming in. I think we ran out of time. I look to Quaid. If we can do more, or
I'd like to direct you, actually, Dr. Hemming has one question that was posted in the chat. If you can maybe address that one, and then if there's time left over at the end, we could maybe have the whole panel answer some questions.
Okay. What's the question?
So the question is, how do you control vegetative versus generative growth, and how do you detect it automatically? Which crop parameters do you use?
Yeah, that's an interesting one. I'm not a crop expert myself, so I have to be careful what effect is what exactly. But it's typically like heating up the greenhouse in the morning, cooling it off in the evening. The way the temperature humidity balance is managed. There is while steering to an optimal 24-hour temperature, you still have room to make choices in what temperature you want as a minimum temperature in the night. Yeah, we call it the diff, so the difference between the day temperature and the night temperature. You can make choices in that within the realistic bandwidth for each specific greenhouse. And that's how we steer towards a more vegetative or generative crop. So this are really typically based on climate. Determining the crop state, that's still what we really work out at the moment. We have good results now from biomass measurements, but we still want to dive deeper into it, how solid this is for every situation. Its combination of biomass and juice flow seems to be a promising combination, but that's something we really look into for the future.
Thanks.